Hello. Let me take you into a short tour of modular circular buildings. Why tour? I believe that circularity resonates well with the idea of the tour. So this is the map of our tour, very simple. We'll focus on a smaller part of it. When we talk about circular construction, I think we talk about taking less material from the nature, taking more material from the built environment. But maybe the less covered topic is actually how do we take it from the existing environment. And I strongly believe that prefabrication and design for manufacturing, assembly and disassembly is a key part in it. So, and I would like to focus on this smaller part of it, and kind of my argument is that we can't take a linear economy and turn it into circular economy, right? We can't renovate our buildings to be circular. Yes, we can renovate our buildings, but they won't be circular buildings. We have to redesign it from scratch. And part of it is actually prefabrication. So my hypothesis is that the higher the degree of prefabrication, the higher level of circularity we can achieve. It's not just about assembling components together, which is about the core idea of design for manufacturing, assembly, and disassembly. It's also about how do we take it apart, right? If we engineer that correctly, our future buildings will be circular. So what is this degree of prefabrication? So it's really thinking about what is, it's the difference between construction, making something on site, and something being produced as opposed to something being produced in the factory, brought on site, and installed rather than built, right? The higher we get to this logic, the better circularity we have a potential for. So we have created this system. It's an open source system, anyone can use it. This is the precursor. I'm standing in one of the modules that is precursor of the system, so the first version. We have quite re-engineered it a couple of times. So it's a great stage, I'd say. And three-cycle system is the primary intention of it is to give this, the platform for all of the topics that we have discussed before. So how can we reuse the wood? How can we use less used wood species? So we approach it from a different angle. Like we say, what do we need? What are the sizes for the components? And that gives you anyone's been on the stage before me, kind of, a frame, where to apply it. So my invitation to all of you is to think about, can we use the material that you're providing in a three-cycle system? It gives us the boundaries to produce. So, and let me just move forward and explain why this is kind of the way that we kind of also need to be thinking about. But before that, I will explain a little bit about the circularity of the system. So it works on many levels. It first works on the building level. So you can quite freely, if you have a defined box, you can quite freely move the components in it. So you can take one module, you can repurpose this module. Currently it's a stage, it can be a small house, it can be part of a kindergarten, it can be a school building or office building. So, and we have kind of tested it with many typologies and say that yes, it can be. Then the next stage is actually the component of it. So talking about the post or the beam or the floor slab. So these are the components that we can reuse now in different buildings. You take one module, you take this end frame away, and you can reuse the floor component. You can take this end frame into beams and post, And these are technically also reusable. And of course, it's timber, right? You can use reused material. However, one of the key elements are connections. I think it was mentioned before as well. These connections need to be reversible. So we need to be able to easy to put together, easy to take apart, easy to put it back together. Yeah, that makes a circular economy. So I'm not going to go into more details, but these are the components I'm talking about, the CLT roof. Can we make that out of reclaimed material? Yeah, technically, yes. Why not? If the engineering is correct, we can use it, right? Recycle provides the platform to actually test it and use it. And the second aspect of reusability is keeping the structure of the building separate from the skin of the building. The external envelope different from the structure. I'm currently standing in the structure. The walls would come on top of the frame. So it would be a balloon frame, new kind of balloon system. So your walls are on top of it, your roof is detachable from the structure. Jumping into a short study we did, it was actually done with this system, so the 369 we called it back then. So we took existing kindergarten, made out, actually built now in Rõõmupesa in Mustamäe, quite close here. So done from concrete mostly, and also partly precast and prefabricated. We redesigned it from using this system and compared the carbon footprint, embodied carbon footprint, without much of optimization. With this, actually, what we have here, we actually reduced footprint 2.5 times. Getting 3 or 4 times better than concrete buildings, I don't think it's a problem. Especially we have these corners, metal corners. So this is a huge, actually. So that's been already redesigned. So we looked at, so nearly 1/3 of the entire module was in the corners and the connections. So, and that's been now kind of redesigned. But even more surprising was the weight of it. So 5 times lighter than the concrete building. And that, of course, builds the basis for the circularity. Okay, let's have a look at what we've already done in the system. It's not just an idea, we've been gone through it. You've seen this building before, so basis of it, Silla was talking about it as well. So base of it was actually one of those modules, M3, which is a 3 by 3 meters. And you can skin it any way you like, really. You can make it local, look it local. So it doesn't have to be, you know, it doesn't look like a box. It can almost look like anything. Electro-Levy Training Center, about 420 square meters, made out of the recycle system, built ready almost 2 years ago by now, and heavily used. And they want to extend it already. So they said they actually started using it so much, and we said, okay, yeah, fine, let's take the roof off again and build another story. Easy, no problem. A little bit harder to extend it from the sides because of the side constraints. But technically, the system, you can take the wall off, add another module, reuse the wall. So that is the kind of basis for it. Inside, we tend to leave it quite simple. So we actually hang technical systems to the frame, so we don't hide them. Also increases the circularity of it, and I think it's the new kind of a new aesthetics. Why do we have to hide those technical systems? The aesthetics of the building should talk about the function of the buildings, I believe. Technical systems are not prescribed. Currently, we're talking about heating of the same kind of panels that you can see here, those white panels for heating and cooling. Yeah? Works very, I think, highly well with the modular system. So now we're getting into more technical systems. So we figured out the architecture, structure of it, and now looking more into kind of modular technical systems. A small summer house built last year So it shows kind of, we've figured out how the electricity should work in terms of modular, and we can actually leave it get quite clean, you know, look and feel of it inside. Couple of technical tests we carried out with both of the two previous buildings. So you know, these are not very good values, but it shows that we are way below the required levels of air leakage. So it's way better than the standards require. But we can get better than that. I think there were a couple of holes in the building. So, but we do actually, I mean, the way we kind of do our science is we actually get it built and then measure, right? Well, that kind of shows technically how it could go together from 3 modules, but the same system would allow, you know, kind of take it apart and build a 2-story building. So we're kind of showing with different kinds of buildings, right? The same module, exactly the same components, maybe different skin slightly, yeah, but also kind of componentized, can be used in different buildings. So that should give us enough confidence and say, okay, there's a system, right? Can we build the components for the system? I would love to see, you know, those components be done from the recycled wood, from the less used, you know, resources from different species. Next buildings, this building is currently being built on Stromi Beach. If you go there, you will see the beginning of it. So ready in a couple of weeks, probably. Well, the main structure. This is currently in design in North Tallinn, 3,000 square meter kindergarten made of the same modules. You can see the modules here. Well, one third of it is not out of modules because it's required by the heritage. And we're now designing the modular kindergartens and classrooms, so for the use in everywhere in, I would say, in Estonia, in Tallinn first, but we also have a commission from Kärdla, so for the pre-stage. And next ones in the line are school buildings. You also saw example we designing in Ukraine, so first 8 points, another building typology, potentially being reused as a school building on kindergarten after the war finishes. So yeah, if you're interested to learn more, come and talk to me. And I'm happy, you know, we really, it is an open source system, so it can be applied without any fees. It's done mostly in the Estonian Academy of Arts, but many engineers who we see here have been part of it. So thank you for taking part of it, and we're looking for further collaborations. Thank you.